Welcome to Study Loop.
Hello everyone, here it is given a slender rod AB attached to the clevis to the arm BCD which rotate with constant angular velocity omega about the center line of its vertical portion CD. We have to calculate the magnitude of angular velocity omega. Let us see here. Here length of AB is given 15 inch. We are representing by L. BC is given 5 inch. We are representing by B and converting into foot. Is that clear? Now let us start solving it. Suppose I am drawing geometrical figure. I am drawing again. This is your AB line, slider AB. It is rotating about this. Consider this is to be x-axis. This is the centroid and this is the y-axis. And this angle is 30 degree. So moment of inertia about x-axis will be 0. Along y-axis and z-axis will be ml square by 12. Here m is the mass of AB. Angular velocity omega can be defined as omega sine of 30 I cap plus omega cos of 30 j cap. So angular momentum of the rod AB about its center of mass G. Angular momentum of rod AB about its center of mass G. You may write Hg we are finding. So it would be Ix omega x I cap plus Iy omega y j cap plus Iz omega z k cap. Ix is 0, so this term becomes 0. Omega z is 0, so this term becomes 0. So you will get angular momentum of the rod AB about its center would be I by omega y, that is omega cos of 30 j cap. Say equation 1. Now angular velocity of reference frame Gxyz omega, which is omega sine of 30 I cap omega cos of 30 j cap. So rate of change of angular momentum about center of mass G it will be rate of change of angular momentum with respect to frame Gxyz plus omega cross angular momentum of the frame about its center of mass. This term is 0. because it is rotating with constant angular velocity. Omega is omega sine of 30 I cap plus omega cos of 30 j cap cross product with I by omega cos of 30 j cap. Now simplify it. So it can be written as, on simplifying you will get it. You have to take the cross product. So after taking the cross product you will get I by omega square sine of 30 cos of 30 k cap. Now substitute the value. I y is mn square by 12. Let me write it properly. Sine 30 is half. Cos 30 is root 3 by 2 k cap. So it becomes root 3 by 48 mn square omega square k cap. Say equation number 2. Now if we see the rotation of the rod or slider AB about center of mass G. So here it will be a normal reaction. Weight mg will be here. It will rotate like this. So this distance you can easily find L by 2. This angle is 30 degree. So L by 2 sine of 30. So radius of circular path of point G is equal to L by 2 cos of 30 plus B. Substitute the value. L is given 1.258 cos 30 root 3 by 2. B having the value 0.41667. So this radius having the value 0.95793 feet. So acceleration of center of mass you can find omega square r in this direction. So couple about the B point. Mg L by 2 cos of 30 K cap is equal to L by 2 sin of 30 M omega square R K cap plus rate of change of angular momentum about G. Substitute the value. So you may write cos 30 is root 3 by 2. Mg L by 2 L by 2 into half M omega square R plus root 3 by 48 M R omega square, sorry, R here is L K cap. This is also K cap. So on simplifying, you may write root of 3 by 4 G is equal to R by 4 plus root 3 by 48 omega square. So angular velocity omega we will find root of root 3 G by 4 R by 4 plus root 3 L upon 48. Now substitute the value 1.7326 into G 32.2 upon 4. Radius is 0.95793 upon 4. L 1.25 upon 48. So on solving it, its magnitude will be 7 radian per second. That's all for it. Thanks for watching it.